Welcome to Study Loop.
This is the answer to Chapter 13, problem number 51 from the Smith Organic Chemistry textbook. And in this problem, we are told that reaction of pentanoyl chloride with lithium dimethyl cuprate forms a compound J that has a molecular ion at 100, as well as fragments at 85, 57, and 43. And we're told that the IR spectrum of J has strong peaks at 2962 and 1718 wave number. And so we are asked to propose a structure for J. And this is another case where knowing the chemistry makes this a lot easier. So this reaction is 100% going to give this as a product. Okay, so that's definitely our product. But we need to look at the spectral data to confirm that. And also, we should try to get there using only the spectral data, since that is the focus of this chapter. And so a molecular ion at 100, we can think about what formula this could represent. So we're going to have an oxygen, and then we're going to have carbons and hydrogens. And so if we assume 6 carbons, that's going to account for 72. We'll leave the hydrogens blank for right now. And then let's say we have 1 oxygen still. So that's going to be another 16. So that accounts for 88 of our 100 mass that we need to account for. So that leaves us with 12 hydrogens. So we can calculate an HDI here. And so that's going to be 2 times 6 plus 2 minus 12 all over 2 is going to be 2 over 2. It's going to be 1. And so this is a good indication that our carbonyl is still intact, our carbon double bond oxygen. And so when we go and look at the spectral data, that bears it out, the IR data. So this peak at 1718 is going to be due to a carbon double bond oxygen. And then this other peak is going to be due to CsP3 hybridized carbons bound to hydrogens. Okay, so from all of this data, we could surmise that that this product that I've drawn here is the correct product. However, just to be further sure, we can look at what alpha cleavage products would look like. And so we have a peak at 85. And to me, 85 equals 100 minus 15. So that's going to be cleavage of a methyl group. And so that does actually correspond to one of our alpha cleavages. So this product is going to have an M to Z of 85. So that's good. And then if we wanted some further proof, we could look at what alpha cleavage on the other side would look like, and it would look like this. And so this is going to be our M to Z of 43. And then as far as the M to Z of 57, that could arise a couple of different ways. So we could say that that's due to cleavage of the alkyl chain. So C4H9 might get us there, or a piece that looks like C3H5O could also account for that. So either of these pieces could be the M to Z equals 57. But everything else considered, this original structure that I drew, the spectral data bore it out. So this is the correct answer. And again, the way to approach this using the spectral data would be to look at the molecular ion peak, try to determine a formula from that, calculate an HDI for that formula, and then look at the IR data to sort of support your conclusion. And so in this case, we had an HDI of 1. A carbon-oxygen double bond bears that out. And then when we look at the fragmentation ions, they confirm that we would have a ketone, and we would get alpha cleavage to either side of that ketone. And so that's the answer to chapter 13, problem number 51.